Good afternoon, students. Welcome to SS classes. Today we are going to start with a very interesting and basic chapter of the chemistry, that is matter in our surrounding. So basically you should know first about the concept of matter. What is matter? Matter is nothing but the everything that present around you. Yes, this TV is the matter, myself is the matter, this fan, light, everything present around us is the matter. Now what is definition of matter? Matter is defined as anything which occupies space. Anything which occupies space and has a mass is called matter. So this TV occupies space and it has mass, so it is a matter. Now basically all the things present around us are matter. Then are there any examples of non-matter also? So yes, many examples are there of non-matter. So what are non-matter? Fine. So thoughts in our mind are matter. Now you will say that, ma'am, thoughts are there in our mind, should occupy space. No, there is no space occupied by thoughts in our mind or in our heart. Fine. So thoughts, affection, love, hate for something, hate for someone, fine, these all things are. Apart from that, shadow also. So these things are non-matter. Fine. So in this chapter we are going to learn in detail about the types of matter and their characteristics. So ancient scientists classified matter into 5 types, that is solid form of matter, liquid form of matter, gaseous form of matter, plasma state of matter, and Bose-Einstein state of matter. So there are 5 states of matter that we are going to learn in detail in this chapter. Before this, you should know about what are the characteristics of matter. So children, there are 4 characteristics of matter. The one is, matter is made up of very small particles called atoms. Every matter is made up of the very small particles called an atom. Now these particles of matter, the second property of matter is, particles of matter have space between them. Every matter's particle have space between them. But there are some exceptions such as solids. Solids do not have the space between them. In other words, we can say the solid particles are closely packed, they are tightly packed. So there is negligible space between them, we can say. That is the reason I am unable to penetrate my hand through this TV. Can I penetrate my hand through this TV? No. Why? Because this is a solid state of matter and there is no space in between the particles of solids. Can we move our hand freely in a water? Yes, of course. Can we move our hand freely in air? Yes. Why? Because the particles of water and the particles of air have space between them. Third is, particles of matter attract each other. Yes, particles of matter attract each other. How one can prove? Now say this is a TV. Fine. So for this TV, many particles are there. And we cannot penetrate our hand through this particle. Why? Because the particles are closely packed. And in order to break this TV, I need to apply a lot of force. I need to apply. So for example, 2 things are there. One is chalk and another is iron rod. One is chalk and another is iron rod. Now if we want to break these 2 rods, one of iron rod and another is a chalk, so where we need to apply a lot of force? We need to apply a lot of force in order to break the iron rod. But very less amount of force is required in order to break the chalk. But yes, force is required to break the chalk. Now why force is required to break the chalk? Because the particles of that chalk have force between them. The particles of chalk have force between them. And when we overcome that force, then only that chalk get break into the pieces. particles of iron rod also have strong force of attraction between them. So when we overcome that force, then only rod can be broken down into the pieces. This activity shows that the particles of matter have the particles of matter attract each other. Last is particles of matter are continuously in motion. Then you will come and say, ma'am, where the particles of this TV are moving? Yes, you will come and ask. So yes, solid particles are not in motion. They are just in a vibration motion. At their fixed place, they are in a vibration motion, but they are unable to change their place. They cannot move here and there. So they are fixed. But at that fixed place, they are continuously vibrating. Fine. But the particles of liquid and the particles of gas are continuously in motion. Now how one can prove? Let us light the incense stick at one corner of your room, and you will get the smell of that incense stick at different corner of the same room. When your mother is cooking something in a kitchen, and if you are sitting in a dining hall, or if you are sitting in your bedroom or some other room, so there you will smell what is going cooking in this kitchen. Fine. So you can identify that yes, sweet is cooking in the kitchen, or something is getting fried in the kitchen, or chapati is getting cooked in the kitchen. So that smell can flow along with the particles of air. It means the particles of food get intermixed with the particles of air, and as the air flows from one corner of the room to another corner, you can smell the different things. Fine. So as the particles of air are moving, as the particles of water are moving, then we can say the particles of matter are continuously in motion. So there are 4 characteristics of matter. Particles of matter are very, very small. Particles of matter have space between them. Particles of matter are continuously in motion, and particles of matter attract each other. So let us see an activity for the particles of matter are very, very small. So children, here is an activity which is activity of your NCERT book. That is the first activity of the first chapter. That is the particles of matter are very, very small. For this, here we have taken the 100 ml of water, and in that we have added few crystals of potassium permanganate. There we have added the crystals of potassium permanganate. These crystals are purple pinkish in color. So as we add crystals into the 100 ml of water, color of water changes to pinkish purple. Now we have to make dilution of this solution. Dilution means what? Dilution means lowering the concentration of a substance, and we can lower the concentration of particular solution by adding water in that. Fine. So for this, for dilution, we have taken 10 ml of a previous solution, and that we have added in 90 ml of water. So we have taken 90 ml of water over here, in that we have added 10 ml of previous solution. So that will form first dilution. For second dilution, we require 10 ml of the first dilution, and in 90 ml of water in next beaker we have added that 10 ml. So that will form second dilution. Now we have taken 10 ml from second dilution, we have added into 90 ml of water. So that will form the third solution. So in this way, if we keep on diluting this potassium permanganate solution, so at the last you will observe that the color of the solution is getting fade, and at the last you will observe the light pinkish color of potassium permanganate solution. What does it mean? It means that the one crystal of potassium permanganate contain millions of molecules of potassium permanganate, and small amount of potassium permanganate crystal can impart its color to large volume of water. It means the particles of this potassium permanganate crystals are very, 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 very small. If we keep on diluting, the color is getting fade. Fine. So it shows that how the particles of that potassium permanganate are small and they can impart its pink color to large amount of water. It means particles of matter are very small. In this activity, we are going to learn the particles of matter have space between them. How one can show it. So in this beaker, we have taken 100 ml of water till the mark of 100 ml, and in that we have added 1 to 2 spatula of salt or sugar. Stir it. So on stirring, the salt or sugar get dissolved in water. And once the sugar or salt get dissolved in water, observe the level of water in that beaker. So what you will observe? You will observe that the water remains at the same mark. Water level does not rise. Water level does not rise. It remains up to the same mark. That is, it remains at the 100 ml of mark. So 100 ml of water is there. In that we have added some salt or sugar. After dissolution, the level of water does not change. It does not rise. It remains constant. Then where does the particles of sugar and salt has gone? The particles get intercalates between the particles of water. It means particles of water have space between them, and in that space the particles of salts or sugar has gone. So that is the reason the level of water does not rise. Level remains there only because the particles of water have space between them. And hence with this activity you can show that the particles of matter have space between them. Third property is particles of matter attract each other. For that I have already told you that break the chalk, break the iron rod. In order to break this material you need to apply force. It means the particles of that substance or any matter have the force of attraction between them. And for activity, that is particles of matter are continuously moving. For that you can give any of the activities. Air can flow, water can flow, incense stick, smoke we can feel from one corner of the room to another corner. Smell of the food we can sense from a long distance. So these multiple examples are there which shows that particles of matter are continuously in motion. So children, our next topic is the comparison between solid, liquid and gases. So let us see what is difference between them. Let us see solid first. So we can represent particles of solid in this way. They are tightly packed, they are closely arranged, negligible space is there in between them. While particles of liquid, they are comparatively free from the particles of the solids. That is, they have the considerable space between them. And we can represent particles of gases like this. It means the particles of gases are far away from one another. So let us see the first property. Strong intermolecular force. The particles of solids have strong force of attraction between them. Weak intermolecular force. They have comparatively weak intermolecular force of attraction. And here is the force of attraction very weak. They are far away from one another. Now here, very less intermolecular space. There is very less intermolecular space between them. Now here, large intermolecular space. Here you can see the lot of space is there between the particles of liquid. And here, very much large space between the particles of gases. They are continuously moving here and there. Large interparticular space is there between them. Yes, solids. Solids have definite shape. This is a solid. TV is the solid. It has fixed shape. It has fixed volume. But in case of liquids, they do not have fixed shape. But yes, they have definite volume. And here, no definite shape and no definite volume because there is no force of attraction between the particles of gases. So they do not have fixed volume also. Now here, solids have high density. They have high melting and boiling point. While density of liquid is comparatively slow. Say for example, we add iron rod or stone into the water. It will sink at the bottom because that is a solid and water is the liquid. So it shows that the solids have high density and the liquids are less dense, while this gaseous are least dense. Fine. So they have the density which is very low. Solids cannot be compressed. This is a T. Can I compress it? Can I compress it from any side? No. Why? Because there is no space between the particles of solids. So we cannot compress the solids. But liquids can be compressed to certain limits, while gases are highly compressible. We can compress large volume of gas into this small volume of container because they have lot of space between them. The question is coming examination, that is why gases are compressible. Justify. Gases are highly compressible. So what you will write in that? You will write that the gases are highly compressible because lot of space is there between the particles of gases, and hence gases can be compressed highly. We can the small container can occupy large volume of gases because they have lot of space between their particle. So this is about the few properties. Apart from that, many properties are there of solid, liquids and gases. So for example, rigidity. The solids are rigid. Yes, they are tough. They are rigid. Can liquids are rigid? No, they can flow. So they are fluid. While gases are also not rigid. Fine. So they are also fluid. So liquid and gases, they have the property of fluidity, while solids cannot flow. So they have property of rigidity. One more property is there, that is called container filling ability. So for example, we have a big container and in that we have kept one chalk. Can that chalk occupy whole volume of that container? No, because solid have fixed shape and fixed volume. If we have 10 liter of container, in that we have added 1 liter of liquid. 10 liter of container, in that we have added 1 liter of liquid. Can that 1 liter of liquid occupy whole volume of that container? No, of course not, because they also have the force of attraction between their particles. The one particle is sliding over the another. They can flow, but they cannot come out of the container. But in case of gases have high kinetic energy. They can flow here and there. They collide with the wall of container in which it is kept. They have ability to come out of the container. So even if we add a small volume of gases in a large volume of container, they can occupy whole volume of container because less force of attraction, high kinetic energy, and they can move here and there in the container. So they occupies the whole container. So gases have container filling ability, while solids and liquids do not have container filling ability. Fine children. So in next lecture, we'll learn about the latent heat. We'll learn about the various methods for the compression of the gases, or we can say the properties, that is what is the effect of temperature and gas on the